Yeah, Sama, you said that the boxes are coming because I want such boxes only in my diagram. Okay, you could see, I need such diagram. If I need only single box here, so I have to give the depth as one, single one. If I need to give more layers, I have to give the depth, define the depth there. Okay, and here what it is actually showing that it is 128 into 128, that are the pixels of the images. This is my images. How dense is my data? Input data is showing by this number of images. Okay, so that is 15. It could be anything, like it could be 512, it could be 64, 128, whatever. Okay, so these boxes are coming. This is actually a diagram, neural network architectural diagram, how to draw this diagram on software tool. So this is how it is shown here. Now this is my second layer. Okay, I can give this second layer anything, like I could give here as a dropout layer also. Okay, dropout. How do you build your architecture depends upon that. So this is my dense layer. I'll just reduce it now. Dense. I'll increase the height and width again here. Height and width. So these are my layers. Okay, these boxes are nothing the layers of my network architecture. So I'm defining here my architecture in this way. I'll increase its height a bit. Increase in height looks good. So this is my second layer. Now why I have taken a bit small, because you know that after the first layer, there are less vectors. Okay, sometimes it happens that the vectors have been reduced in max pooling or dropout. So I have reduced this vectors. If I go for the third layer, okay, there are mostly 4 to 5 or 6 layers. So I'll just go on adding this. This is actually one tool which is used to draw these things directly, taking into paint and drawing each boxes and overlapping on them and when we want to shift the whole layers, so taking each and every block, shifting it again and again, so that won't do, isn't it? So instead what we are going to do, we are going to use this tool where it is going to do automatically. It is drawing an automatically neural network for us, an architecture of neural network for us. Now here, after taking, suppose I mine has only 3 layers here, and with this output layer and one is fully connected layer shown here, if I minus this much, so what I'm going to do is I'm going to take this diagram, I'll download this svg. When I download this svg, the document is in svg format. Okay, I'll save here on the desktop, and here this is my diagram which I have downloaded. Got it, students, how to work on this tool? So this is an online tool available to draw the neural networks. So this is only what I wanted to show you. Fully connected style means you have all the neurons you are showing here, neurons connected to the neurons after the first layer. Each neuron is interconnected to all the neurons. Okay, so after first layer, obviously vectors have been reduced and reduced and reduced. So how to get this reduced vectors? So for that also you have this architecture given here. Increase or decrease the layer neurons here. Okay, and finally you can draw the architecture in this way also. Suppose yours are 6 layers, so you have to 1 2 3 4 5 6, you can go on adding till 6 layers. One, 2, 3, 4, 5, 6 layers. In the sixth layer I have 10 genres, for example. So 16. I've randomly taken these values. You can take accordingly as you wish. So this could be a fully connected layer. So it is really very impossible to draw such things, isn't it? So I can draw this. I can give the colors here. Negative, edge colors. I'll give all the light shades here. Mhm. Not getting those light shades. This is a default edge color. So this is the color what I've got, edge opacity. So I don't want any edge opacity. So it's full. Okay, edge width. If I increase, I'll get the edge widths. And you can change this all these things here with node colors. Now if I change this with node color, I'll take some other color, blue color. So it will appear in blue colors. The nodes will appear in blue colors. Node borders with blue with the green border if I give. So 7. Okay, that is not been seen borders, but border color is now this one. Okay, then the direction is horizontal or vertical. If I want to change it into vertical direction, it could be in this way. Here it is showing the layers name and all everything you could see here. Hidden layers, hidden layer 1. This is input layer, hidden layer, hidden layer, hidden layer. Finally, the output layer. Okay, so I'll keep it horizontal. The names have been appeared here. Let's see. It is 137 nodes, 2821 edges, means all the connections, 2821 edges. You don't need to draw yourself. Show bias units, show layer labels. These are the layer labels. Show arrowheads. They are showing the arrowheads here. Okay. Or it's just simple solid arrowheads. So I'll give an empty head or I won't show only. So that is all. So this is for fully connected neural network. And this is LayNet is LayNet actually full form of LayNet. I've written there something, but I don't remember now. Okay, this architecture itself is called as LayNet. Okay, so if I want to go for FCNN style, fully connected, or LayNet style, or AlexNet style, so it depends. So AlexNet style forms fully a 3D architecture type. So this is a webs, and this is with the SVG. Okay. Convolution filter scaling depends upon. So here it is. If I give a convolutional filter scaling, filter size scaling, you could see that it is showing for each and every layers till the output. Okay, here. If I don't, it won't show me. Okay, it is still showing, but it is giving the diagram in different way again. So I'll go into the logarithmic, which is giving me the smaller size of filters here in the inbuilt filters. And depth size scaling. Okay, I don't want that depth. Okay, this feature size, feature maps with scaling. So width will be increased. This will be increase the length and the filters inside it is will. It's not showing. So this is with the SVG of AlexNet style. If I go with the web one, so it is something different with it. Okay, now it is showing tensor dimensions. Here you could see the dimensions. The dimensions given here. And this is showing the conventional dimensions. So this is not actually required for the diagram purpose. So we won't we bother take this and we can again download this or save this file and there we are done. So these are the three styles. Just we have to download whatever we have drawn, download it, and you are with that. AlexNet style, why it's not okay? If we go for F, then we can download SVG. WebGL is not been downloaded. It's only for the viewing purpose. So for downloading, we can download with the SVG files. So this is with the SVG tool. Very nice tool to be done for neural network connections, to show the neural network connections in the diagram. You can't draw each and every networks or connections. So here you can draw it very easily. Very nice tool available online. So that's all. Any difficulty, any doubt, you can ask me.